Here we have a review for section 3.1 for triangle congruence theorems as well as isosceles triangles. So to review, there were five types that we talked about, 5 different postulates that we talked about for identifying congruent triangles. So side, side, side means that all 3 sides are corresponding pairs. Side angle side means that you have 2 sides and an included or between angle. So if I have this side and this side, those are my 2 sides, then the only angle that I care about is the one that's between them, and that's the angle that has to be congruent. Angle side angle means I'm looking for 2 angles and the included or between side. Remember that included means between. So if I have 2 angles, then I care about the side in between. So there are my congruent angles and the side in between. It can be any combination of that order anywhere on the picture. It just has to be at least in that order. Angle, angle, side is 2 angles and the side opposite. Our other direction said the non-included. That means the one not between the angles. So that if I have this angle and this angle, it's an angle that is not between them. So this angle and a side that is not between them. Hypotenuse leg is specific to right triangles. And once I have right triangles, if I know that a leg and the hypotenuse have corresponding matches in another triangle, right triangle, then I know that those 2 triangles are congruent. Here are some reasons for congruent sides. It's given. That's the easiest one. Some of the other ones that we can use are the definition of a midpoint. It creates 2 congruent sides. So if I tell you that something is in the middle or the midpoint, you know that both pieces equal each other. And the last one is the reflexive property, means that a side is congruent to itself. Reasons for congruent angles. So again, we start with it's given. That would be from the diagram. We know lots of things and have seen lots of examples of vertical angles. Because of our work with parallel lines, we know about alternate interior and corresponding, but I have to have parallel lines. And the last one is the definition of a bisector. Bisect means cuts in 2, and that'll give me 2 congruent angles. We also talked about CP-CTC. Corresponding parts of congruent triangles are congruent. So if I tell you that those 2 triangles are congruent, then I know something about the sides and the angles. I know that AB is congruent to DE, and I can get that both from the name and also from the picture. I know that BC is congruent to EF, and I know that AC is congruent to DF. But I also know something about the angles. I know that angle A is congruent to angle D, And again, I can get that from the location in the name or from the picture. I know angle B is congruent to angle E. And I know that angle C is congruent to angle F. So these are all things that we've talked about as how to prove congruency and statements about that. So let's look at some examples. I'm only asking you to determine whether they can be proven congruent by one of those theorems, postulates. So what do I have? I have one congruent angle, two congruent angles, and a common side, which means that side is congruent. So in order, I can say angle, side, angle. So that's the postulate that I can use to prove that. For number 2, I'm given two sets of congruent sides, and I know that this is the same line. So therefore, it's congruent. So again, I have side, side, side. In order, with nothing in between, so I can say that this is side, side, side congruence. For number 3, I have two pairs of congruent angles, and I have a side that is not included. So that means I have angle, 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 and side. That means I can say that these are angle, angle, side congruent. Now, number 4 has a right angle. So that's going to automatically be putting me in looking for hypotenuse or leg or acute angle. There are no other angles identified, but I do have a leg, and the hypotenuse is the same side or shared by both things. That means that I have a hypotenuse and a leg, which makes this hypotenuse leg congruent. So then we look at number 5. And number 5, I have two sets of congruent lines, and I know that these angles are congruent because they're vertical. But what I've been given is side, side, angle. And side, side, angle is not a theorem. So these are not congruent. For number 6, this one is an extra because I have a side and an angle. And then when you look at it, I don't have any vertical angles. I don't think I have anything else until I recognize that these are parallel. So I like to extend my parallel lines. And then I like to extend my transversal. And then I can see that, lo and behold, these are corresponding angles. Corresponding angles are congruent. So now I know that I have angle, side, angle to prove congruence. So I use corresponding angles. So then we look at number 7. And number 7, I have one pair of sides and an angle. And I know that this side is congruent because of the reflexive property, because it's a shared side or the same side. So then I have side, angle, side for congruency. Number 8, again, has a shared side, so that side is congruent. So then I have side, side, side for congruency. For 9, I have right angles, so I'm going to be looking for hypotenuse, leg, or acute angle to figure this out. And I have 2 sides, so I'm looking at these. And I can see that I have a hypotenuse and a leg. So that gives me hypotenuse, leg for congruency. For number 10, these are vertical angles, so they're congruent. So then I have angle, angle, side that I can use for congruency. When I look at number 11, I have one pair of congruent angles, okay? And I know that this side is congruent, but that's all I have. I don't know anything about the other angles or the other sides. It's not a straight line. I don't have any vertical angles. So all I can say is that with the information given, these are not congruent. For number 12. The first thing that I notice is that these are vertical angles, but that gives me side, side, angle, and I know that that's not anything I can use. So then I take note of our parallel line symbols, and I extend my parallel lines and my transversal. And then I can see that this angle and this angle are alternate interior angles, and they're congruent. So now what do I have? Now I can say angle, side, angle. Or I can say side, angle, side. But I couldn't have done either one of those without recognizing the alternate interior angles. So that's just identifying how the triangles can be proven congruent. So now we move back to isosceles triangles. And we start with the idea that the 2 congruent sides of an isosceles triangle, as shown in the diagram, are called legs. The angle where the legs intersect is called the vertex angle. The side opposite the vertex angle is called the base, and the angles along the base are called the base angles. Oops. So we've talked about the two theorems for isosceles triangles. The first one says if the two sides are congruent, then I know something about the angles. So if AB is congruent to CB, then angle A is congruent to angle C. We can also go the other way and say if I know the angles are congruent, then I know the sides are congruent. So then I can state that if angle A is congruent to angle C, then I know that AB is congruent to side CB. So to use those theorems and apply them to triangles, we're going to start with this basic one in number 1. And because this is the angle across or opposite the congruent side, that means this is 68. So J is 68. And to find K, it's 180 minus 68 minus 68, which is 44. And that comes from our triangle sum theorem. For number 2, this is the vertex angle, or the non-adjacent. That means that C and E are congruent. So to do that, we say 180 minus 106, and then that is divided by 2 to give us C and E. So that gives us 37 degrees each. Because I know that whatever 180 minus this, whatever it is, I have to divide it in 2 for these two angles. For number 3, this one uses the side theorem. So this is the side opposite that angle, and that's the side opposite the other base angle. That means that YZ is also 12 centimeters, because if the angles are congruent, then the sides are congruent. And then to find angle Y, it's 180 minus 77 minus 77. And that's angle Y, and that is 26 degrees. For number 4, it's the same properties. Now we add algebra. So these are the base angles. That means that they're congruent. That means that 5x plus 9 equals 8x minus 30. So then we solve for x by isolating, and I get negative 3x plus 9 equals negative 30. Subtract 9 from both sides, and I get negative 3x equals negative 39. And we divide by negative 3. Don't forget that. X is 13. For number 5, again I have the base angles. Those are the ones that are congruent. So that means that 4x plus 7 equals 9x minus 33. Subtract 4x from both sides and add 33 to both sides. so that I get 40 equals 5x, divide, x is 8. Numbers 6 and 7 talk about the sides of an isosceles triangle. So we start with, these are the legs because they are the ones opposite the base angles. That means they are also congruent. That means that 15x plus 7 equals 23x minus 17. By subtracting 15x from both sides and adding 17 to both sides, I get 24 equals 8x, divide by 8, x equals 3. For number 7, these are my congruent angles, therefore these are my congruent sides. That means that I can set up 3x plus 23 equals 9x minus 73. Subtract 9x from both sides and subtract 23 from both sides. Notice that one thing cancels on each side of the equation. Negative 6x equals negative 96. Divide by negative 6, x equals 16. For the last part, this is a review of proofs and how we can prove that things are congruent. So the first thing we do is write down the givens. I know that L is midpoint of KN and MP, and that's given in the instructions. What that means, because it's the midpoint, it creates two sets of congruent sides. So that means that I can say M L is congruent to LP by the definition of midpoint. And I can say that KL is congruent to LN because of the definition of midpoint. Midpoint means that it cuts a line in half. Now, I also know that these are vertical angles. So that means I can say angle MLK is congruent to angle PLN because they're vertical angles. So now I have side, angle, side. So I can say triangle MLK is congruent to triangle PLN MLK PLN. Yep. Using side, angle, side congruence. So we stated what we were given, what that given told us, anything that we could see from the picture, and then if that was enough, we have our congruence theorems. For number 2, our first thing, BD bisects angle ABC, which means Oh, and I know that angle BAD is congruent to angle BCD. So BAD and BCD are here, and that's given. And actually, there's enough space here to put that down here. And oops. Angle BAD is congruent to angle BCD, and that's also given. Then I know that angle from the word bisects, I know that angle ABD is congruent to angle CBD because that's the definition of angle bisector. It's an angle bisector because it bisected an angle. So that means I know that this angle and this angle are congruent. Now, looking at my picture, I see a common side. That means that that side is congruent. So I can say that BD is congruent to BD because of the reflexive property. So now when I look at my picture, I have angle, angle, side. I can say that triangle ABD is congruent to triangle CBD using angle, angle, side as my reason for congruence. So again, what we were given in the picture, what that means for anything in there, anything that I see, and then of course being able to prove congruence. Our last example, we start with all of our givens. So you just write them down in separate statements. So the first thing I know is S is the midpoint of QU, and that's given. So I'm going to go right ahead now and mean that means that those two sides are congruent. And we'll get to that in a minute, but that's what bisects or midpoint means. And then I know that QR is congruent to ST. So QR is congruent to ST. And I knew that RS is congruent to TU. Is congruent to TU. And those are all given to me. Now, how did I know this? I know that QS is congruent to SU because that's the definition of midpoint. So now when I look at my picture, I have side, side, side. So I can say triangle QRS is congruent to STU, triangle, using side, side, side congruence. And that's our review for 3.1.